community. Welcome back to the IoT Programming course. This course is based on the book IoT Programming with MaTouch ESP32S3 1.28 touch. The goal of this course is to help you quickly learn the basic development of IoT applications based MaTouch 1.28 touchless controller. In this lesson, we will explore how to connect your MaTouch to the internet and exchange data using two of the most common IoT communications protocols, HTTP and MQTT. Now, let's start with HTTP. HTTP is a request-response protocol in which the client sends a request to the servers, and the servers replies with a response based on that request. For example, when you need to send a message or request weather data, your device acts as the client, sending a HTTP request to a server. The server then processes the request, generates a response, which may include text, JSON data, images, or even files, and send it back to the client through the send connection. Each HTTP request consists of several parts: the methods, such as get or post, the URL, and the handles and body. Okay, let's learn how to send a HTTP request via Wi-Fi to Open Weather Map to fetch JSON data containing fields such as temperature, humidity, and weather code, and then display the information on the screen. Open Weather Map is an online service platform that provides global weather data. Developers can access real-time weather forecasts and historical weather records through its API interface. Log in or create an account. Copy the API key. Now, we can retrieve weather information using an API key. Let's see how this is implemented in the code. By scanning the QR codes in the book, you can download all the example codes used in this course and send this to your computer. Open the file HTTP weather. Change your Wi-Fi information. Pass the Open Weather Map API key. Define the city for which you want weather information and the unit of measurement. Define API request URL. The URL contains all necessary parameters: city, country code, temperature unit, and API key. For the requested URL, you can find other formats in Open Weather Map, such as retrieving weather information by altitude and longitude, city name, city ID, and so on. In the setup function, the main part is connecting to Wi-Fi. Within the load function, the primary task is to update weather data, and it refreshes every minute. We can examine what get weather data implements. Firstly, change Wi-Fi connection status. Because HTTP requests require an internet connection, create an HTTP client object. Initialize request URL. Send get request and get response code. If response code is greater than 0, the request was successful. Get response strings content. Extract weather information and display on the screen. With that, the code portion is complete. Use Type-C USB cable to connect the board and PCs, and click the Touch menu. Then, select ESP32S3 test models on the board. Choose the collect point, and set USB CDC on book to enable. Click the Upload button on the Arduino IDE and wait for the code to upload. The screen displaying the weather information normally. Next, let's look at the MQTT. MQTT is a lightweight messages protocol designed specifically for IoT. Implement the MQTT protocol requires communication between a client and a server. During these communications, MQTT defines three roles: publishers, brokers, and subscriber. Both the publisher and subscriber are clients, while the broker acts as the server. A message's publishers can also be a subscriber at the same time. The contents published includes the published topics and message. Subscribers must subscribe to a topic to receive message published under that topic. Okay, let's learn how to use the MQTT talk to communicate with the MaTouch. MQTT acts as the publishers to send message, while MaTouch acts as the subscriber to receive and display the message on the screen. Open the file subscriber. Change your Wi-Fi information. Create network and MQTT client objects. Define MQTT brokers, servers objects, and client numbers. Define the subject information. Connect to the Wi-Fi. Connect MQTT brokers server. Set up a message reception callback function. When a MQTT message is received, the code will enter the onMQTT message function. Within the onMQTT message function, the primary implementation displays the received message on the screen. Subscribe to topics. Within the load function, process MQTT communications. Inspect and receive message. With that, the code portion is complete. Use Type-C USB cable to connect the board and PCs. And click the Touch menu. Then, select ESP32S3 test models under book. Choose the collect point, and set USB CDC on book to enable. Click the Upload button on the Arduino IDE and wait for the code to upload. Now, when a topic we are subscribed to post news information, it will appear on the screen. Install MQTT Talk on your mobile phone. Set the MQTT brokers, servers, and point. Click the Connect. Click the Publish. Set the topic and message. Click the Publish button, and you will see the message is displayed on the screen. After starting, let's compare HTTP and MQTT. HTTP uses a request-response model, is stateless, and better suited for REST servers and APIs. While MQTT uses a publish-subscribe model, keeps persistent connections, and excels in real-time, low-power IoT communications. Congratulations on completing Lesson 5. Thanks for watching. Bye!